Hey guys, I'm back for question 4 of the 2012 NCEA Level 2 Physics Mechanics paper. This is question 4. This is the last question in this test. Yeah, I'm just going to get straight into it because I don't want to stay up. I don't want to be doing this for too long. Okay, so basically, the clown makes his entrance riding on the cart pulled by Hannah. The clown and the cart have a combined mass of 85 kilograms. The handle of the cart makes an angle of 30 degrees to the horizontal as shown in the diagram below. Hannah applies a force of 55 newtons to the handle. Okay, so calculate the size of the horizontal component of the force on the handle. Okay, so this question is basically just using SOHCAHTOA again, and it's just using so sine, cos, and tan rule to find out in a right angle triangle. Okay, so I'm just gonna make this a bit more clear. Okay, this might be a bit unclear to some of you, some people. So this arrow is really screwed. I'll try again. Okay, so so we can just see we can make a right angle triangle, right here, and this right angle triangle right here, that's 90 degrees. Okay, it's not gonna work for me, but that's fine. You know that's 90 degrees in the corner. You have 30 degrees with the horizontal, and this way by 55 newtons. So you're trying to find, so if the angle is here, then this is the opposite side, this is the hypotenuse, and this is the adjacent side, okay? Okay, so you have to think of it, so you have to think of it this way, okay? So we are trying to find out the horizontal component, which is this, f of x, and that is the adjacent side, and we have the horizontal side, which is given to us by the question. So what involves both adjacent and hypotenuse, sol, ka, or toa? Well, obviously it's ka, because ka has both a and h involved. So we're going to use the cos rule, obviously. So we're going to say cos 30 is equal to a over h. You already know, it's told you that's 55 newtons, so you can directly say a over 55. So you can just say cos 30 multiplied by 55. So cos 30 multiplied by 55 equals to a, and that should be giving us cos 30 multiplied by 55, 47.63 newtons. Alright, that means the horizontal component is 47.63 newtons. And that's pretty straightforward. You should be getting an achieved grade for getting to final answer with the working. Alright, next question. B. The cart is in equilibrium. State what equilibrium means in terms of the forces acting. Describe what it tells you about the velocity of the cart. And on the diagram above, draw labeled arrows showing the direction of any non-vertical forces acting on Hannah. Okay, so this question is it's something that we probably went over quite a few times in class. Okay. So what is equilibrium? Okay, that's the question here. What is equilibrium? So basically, equilibrium is the balancing of the net force. So net force equals to 0, and the balancing of the rotational forces. So torque net also equals to 0. That means for F net, the forces acting right is balanced with the forces acting left. The forces acting upwards is balanced with the forces acting downwards. They all cancel out to equal 0. Therefore, there's no F net. And for torque, that means there's just no torque. The torques are balanced on the pivot, both sides of the pivot, and therefore the torque is balanced, and therefore there's rotational equilibrium as well as equilibrium for the forces. Okay. So because equilibrium, so what does that have the effect on the velocity of the car? So when you have an equilibrium, that means the F net equals to 0 and the torque net equals to 0, okay? So let's just say F net first. So if the F net equals to 0 newtons, then you know that F equals to ma, right? If F equals to ma and F divided by m equals to a, because F net is 0, so 0 divided by m, 0 divided by anything is 0, so therefore the acceleration must also be 0. Because the acceleration is actually 0, then therefore the velocity is not changing. The velocity is constant. So therefore the cart is either moving in a constant speed or it is stationary and moving at 0 meters per second. Okay. For rotational forces, that means there is the torque net is equal to 0, and that means there's no rotational acceleration in any direction. It's just rotational equilibrium, okay? It's pretty similar to the F net explanation, okay? So basically just it's constant basically, because this equilibrium. Okay, so let's answer this question. Okay, so first we have to state what equilibrium is. Okay, so we can basically just say equilibrium is when the F net equals to 0 newtons and the torque net equals to 0 Nm. This means that all the forces acting on the cart can cancel each other out so that no force is stronger than another. Sorry, that says stringer. That's cringy. Stronger, okay. No force is stronger than another, okay? So no force is superior over another, okay? And I'm also going to say the net torque is equal to 0 Newton meters, meaning that the torques are balanced on both sides of the pivot, and this means there is no rotational acceleration. Okay, so now we're done explaining what equilibrium is. We haven't explained what effect it has on the velocity, okay? So, because there is no unbalanced forces, this means that F net equals to 0 newtons, and because F equals to ma, and F divided by m equals to a, because F equals 0 newtons, 0 divided by anything is 0. Therefore, no acceleration, and therefore the velocity is constant, or the object is not moving. Okay, I think that should be it. That should be a good explanation on what equilibrium is and how it affects the velocity. We'll move this up a little bit more so you can see it. Okay, so you can see it now. So the middle question, so the last bullet point is, on the diagram above, draw labeled arrows showing the direction of non-vertical forces acting on Hannah. So only the horizontal forces acting on Hannah, okay? So basically this should be practically some level 1 stuff here. So basically Hannah provides a push force, which is a thrust force, which is going in the direction of direction of her thrust force. And there's also a friction force acting in the opposite direction, okay? Okay, so remember that because the F net equals to 0, right? These two arrows should be at approximately the same size. So just when you're drawing the arrows in the actual exam, just make sure that they're approximately the same size, or else the marker has an excuse to mark you down for that, okay? So just make sure of that. So these two arrows, we're going to name the forces. So the forces acting this way would be friction, acting to the left. And then Hannah provides a thrust force. Okay, so marking for this question, if you get everything correct, arrows correct size, and that you get a merit grade. If you only get one arrow correct, it's an achieved grade. Any one of these two arrows to get you an achieved, okay? Yeah, just remember the size of these arrows have to be similar, because F net equals to 0, okay? Alright, moving on. Explain how Hannah can make the cart and clown accelerate without changing the size of the force she exerts on the handle. Reducing friction is not a possibility. So I don't know if you guys remember or not, but when we had that topic test during the end of term 1, we had like the exact same question. It's like pretty much the exact same question. Okay, so I'm gonna explain it nonetheless, but you can exit here if you're confident with this. Okay, if you're confident with the idea of decreasing the angle theta, then you can stop watching here. Okay, there's no need for you to stay. But if you're not confident, then you're more than welcome to stay and hear me out. Okay. So explain how Hannah can make. We already read that. So in this diagram, you see there's a force acting this way. It's a 55 Newton force provided by Hannah, and there's an angle theta of 30 degrees. Okay, so the way that Hannah can make this car accelerate without changing the amount of force she exerts is by changing the angle theta that she makes with the horizontal. If she decreases the if she decreases the angle she makes with the horizontal, that means that there's more horizontal component and there's less vertical component. Because it's vector addition and the horizontal component added to the vertical component should equal 55 newtons. As we move the angle theta down, then the horizontal component will get bigger, while the vertical component will get smaller, okay? Because the horizontal component gets bigger, right? That means there's more force acting in the horizontal direction, and that means there's now an unbalanced force acting in that direction. Because there's an unbalanced force acting in that direction, and then F equals to ma, mass is constant, so like the mass doesn't change. We're not like taking the wheels off. We're not like doing anything stupid. So the mass of the cart should be the same. And because we now have a net force. We have now net force acting in the thrust direction. So we have F divided by m equals to a, and that will give us a numeric value for a, which means now we have an acceleration moving in the thrust direction. Okay. So that's basically it. We just have to write it down in words now. Okay, so how are we going to write this out? Okay. So basically, if we decrease the angle theta, so first we have to mention we need to decorate. That's funny. Decrease the angle theta that the let's just say the handle makes with the floor. By doing this, we are increasing the horizontal component of the force, and therefore we are increasing the horizontal component of the force, and therefore decreasing the vertical component. Therefore, there is now an unbalanced force acting on the cart, and therefore the cart will begin to accelerate in the direction of the unbalanced force. Because F equals to ma and m is constant, we can say F divided by m equals to a, and because there is now an F net, there will be a numerical value for acceleration. Hence, the cart is now accelerating in the direction of the thrust force. Okay, that should be our answer here. And just move this down a little bit. Okay, so that's basically the answer. So you're decreasing the angle theta of the handle on the floor. You're increasing the horizontal component as a result, and because you increase the horizontal component, the forces are now unbalanced. Because the forces are now unbalanced, there is now an F net, and because F is equal to ma, and F is divided by m, there is now a numerical value for acceleration. Hence, the car is now accelerating in the direction of the thrust force. For merit, we only state that we decrease the angle theta of the between the handle and the floor, and we state that it increases the horizontal force. We don't make any link to F equals ma, and we don't make any link to unbalanced forces. So that's merit. For an achieved, you only state by decreasing the angle between the handle and the floor. That's only basic judgment here. So you're probably aiming for excellence. So remember, you have to link it all the way. Linking decreasing angle theta to increasing horizontal component to unbalanced forces to constant mass to F equals ma and F divided by m equals a, and therefore acceleration. Okay, linking it all the way. Okay. All right. Thanks for joining me on these 4 questions of 2012 physics level 2 mechanics. Hope you enjoyed, and hopefully you learned something and you feel more confident in the standard. If there's any questions, please comment down below. Any constructive criticism, please also comment down below. And please leave a like and subscribe. And yeah, have a good day and peace out. See ya.